Welcome back, MEFB 2013-213 manufacturing processes. So we are in pressworking topic, and let us continue from where we left the last, right? So we spoke about the presence of different presses. So if you remember, the different types of presses that were available: the inclined open back press, gap press, arch press, straight side press, horn press. Okay, and then we looked at the different types of shapes of presses available, and each types of frame had its own function. For example, a gap press was used for long wide parts, arch press for light work, straight side press to take heavy loads, okay, and horn press for cylindrical parts. Okay, so each and every press had played their own role. Okay, then we have now we look at the drive mechanism for presses. So what is a drive mechanism? Yeah, so drive mechanism is actually the source or method of generating power in a press. Okay, so normally drive mechanism uses the torque coming from the motor to generate power for the press to move or for the press to function. So you have a single crank drive. Okay, single crank drive it gives a harmonic motion. It reaches its maximum speed at mid stroke. We have an eccentric drive. Eccentric drive gives shorter strokes than the crank drive. Rack and gear gives long and length control strokes. Hydraulic drive, it gives slow powerful motion of the ram for forming and drawing operations. Then we have a knuckle joint drive. It is used for coining because of its high load capacity. Toggle drive, screw drive. So these are the examples or the pictures of your drive. Here you have a single crank, eccentric, rack and gear, hydraulic. Okay, and feed mechanisms of presses. As I told you, presses are generally more manually designed. Therefore, the feed mechanism or the way you put in your raw material to obtain before you obtain your finished product is by a feed mechanism. Yeah, so a feed mechanism is like a system that is being incorporated into a press machine to automatically feed parts into the system, so you do not have to endanger the hand of the operator. So presses, like I mentioned to you previously, yeah, presses employ tools called punches and dies. So the punch has a punch holder, the die has a punch holder. The punch has a punch holder to hold it in place. The die has a die holder to hold it in place. So both punch and die works hand in hand, just like in sand casting, where you have the upper half and the lower half which of the mold, which is the cope and drag. Okay, and in die casting we call it the movable half and stationary half. Similarly, here in press working we call it the punch and the die. Okay, so punches are attached to the ram. So a punch together with the ram enters the die cavity. The die is usually stationary and rests on the press bed or a bolster plate. So if you recollect, in the previous slides, this is your press machine, right? So this is your ram. Okay, so like I mentioned to you, your punch is attached to the ram, correct? So this is your ram. Your punch is actually attached to your ram, and and this is your die has a die holder. So the punch and the ram moves together to stamp on a part or to shape a part simultaneously. Yeah, so this is one whole system. And where does your part sit? It sits on a die block, and the die block is supported by a bolster plate. Okay, so this is your part, yeah, the metal strip. It sits on the die block. Die block sits on a bolster plate. Okay, so there are three major operations in a press. So a press machine can perform three major operations, which is number one, shearing or cutting. Number two is bending and forming, and number 3 is drawing. Okay, so let's look at the first one here. So the first one is shearing. So shearing is the process of cut along a straight line across a strip to produce small pieces of sheet metal. So again, as I always told you, is this confirm the moment the word shear appears, confirm that it falls in the region CD of the stress strain curve. Okay, so shearing applies shearing forces, that means must be greater than the ultimate strength of the metal. So when you shear a material, okay, when you shear a material, you need to apply a shearing force, and for you to actually fracture or cut the material, your force must be greater than the ultimate strength of the metal. So you must be able to overcome the ultimate strength of the metal in order for you to cut the object. And obviously, generally, for you any shaping process, the metal needs to pass from the elastic. There's no deformation, right? Remember, it's like rubber band, stretch, let go, will come back to its original position, and plastic deformation to the state of ultimate strength. At this moment, fractures start to take place and they progress with more shearing forces. Okay, there are different types of shearing operation. So now you have a blanking operation. So let's look at it. Okay, if you look at this diagram, yeah, so these are the several types of operation that can be performed using a press under the category of shearing. So first of it is blanking. So blanking is you have a sheet metal material, and then you create when you punch out a certain dimension from that sheet metal material. So what is the remaining called? The discarded waste or the remaining material. So when you punch out or you machine out or you cut out using a press this particular shape, now you're left with this extra material, which is discarded waste or useless material, which we call skeleton. Okay, so this is the required blank and it's surrounded by skeleton. Okay, then you have slitting. Slitting is just to cut a strip of material. Okay, then you have punching. Punching is you can punch holes on the material. Okay, then you have notching, when you create sharp edges on the sheet metal. So normally you do notching on the edges of the material. Okay, here on the edges of the material you will do notching, like sharp edges of the material. Okay, then you have something called lancing. Okay, what is lancing? Yeah, so if you look back at this here, so you have blanking. It refers to operation of cutting out sheet metal blanks or flat shapes from strips. So like I just showed you earlier, all the remaining material that is not utilized would be called a skeleton. So normally the skeleton would be melted and it will be recycled to a new material again. So piercing or punching is when you cut or enlarge a hole. Nibbling, when you create overlapping holes. Okay, so this operation is similar to the making of an elongated slot in a sheet of paper by successive punching of holes. Shaving or sizing is when the extra material from a roughly sheared edge is trimmed. Slotting is when you cut an elongated hole. What is an elongated hole? Yeah, when you slot a material. Okay, so you have a sheet metal. Okay, so when you slot, so this is a slotting. Yeah, this is a slotting. Okay, so we call this a slot. So this is a slotting operation. Yeah, so nibbling is when you create overlapping holes. Okay, so when you have a sheet metal material, you create overlapping holes. Okay, so this is called nibbling. Okay, here, nibbling, when you create overlapping holes. The top one is slotting, the second one down there is nibbling. Okay, so eventually it will look like a long slot. Yeah, so then you have shaving or sizing. So shaving or sizing is when you remove extra material from a roughly sheared edge. Okay, slotting, very clear, it's the same as cutting or enlarging a hole. Yeah, you're just creating a slot. Okay, then you have notching. So normally notching is when you remove sharp edges from the sides. Okay, notching when you remove sharp edges from the sides. So if we look at this, this is notching, yeah, when you're removing the sharp edges from the sides. Okay, so that is notching. Then you have perforating, when you randomly, okay, so perforating is when you randomly create or punch holes on a material. Okay, so you can bond it. Okay, so this is perforating. Okay, you see it, perforating. Okay, then you have slitting. It's longitudinal cut of a strip. It's just to cut one strip of material. And then lastly is lancing, leaving a tab without removing any material. So when you say leave a tab, you're going to create an indent on the material. Okay, so when you get your exam slips, yeah, if it's or any private and confidential letter, you'll have these broken edges, correct? So what these broken edges do, you are going to bend the broken edges, and then you tear off the sides, right? And then only you can open up your letter. Similarly, this is a material. This is lancing. This is this is lancing. Okay, we look at this. This is lancing. So you're going to create indents on that sheet metal material. Why are you creating indents? If you don't create that indents, and then you when you bend the material, you're going to not bend it properly. So normally, if you want to get a sharp 90-degree bend, you must make sure that you do this. You are going to indent the material. You create an impression on the material. Once you have indented the material, and on that you are going to perform the bending, you will definitely get a sharp bend. If you do not, this is a sharp bend. If you do not do the indent, you're going to get a curvature bend, or not a sharp bend, which is it's not going to look good. Yeah, so these are the different operations performed under the category of shearing. Okay, the next one, bending and forming. So bending and forming is when you bend your sheet metal materials to a V shape or U shape. So that is basically performed in room temperature. If you had been to a manufacturing lab, yeah, you'd have seen a bending machine there. So you basically put the sheet metal through it and you perform the bending. Yeah. So here, this is your bending machine. This is your bending machine, and this is your sheet metal when you produce a bend part. Okay. So this is a V bend. This is a U type of a bend. Yeah. Then you have drawing. So you can either have a single action drawing or a double action drawing. Okay, so it's performed on a single press or a double press. So why is hydraulic presses suitable for drawing? Because of the slow action of the press. So like I told you, when it's slow or it moves slowly, gradually, the sheet metal or the material is gradually stretched, and there will be even thickness all throughout the material. If you drastically stretch the material, then you'll find uneven density or thickness of the material. Yeah, the speed can be controlled. It has got uniform squeezing pressure and the strength of the press. Okay, so that ends this chapter. Thank you very much. I will see you in class tomorrow. Please make sure you complete your assignment. Due date is on Wednesday. Thank you very much, class.